Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 719, which is find kth smallest pair distance. Let's see the problem description. The distance of a pair of integers a and b defined as the absolute difference between a and b. And given an integer array nums and an integer k, return kth smallest distance among all the pairs nums and nums where 0. This is the condition. Okay. And let's see the constants. The length of the given nums array will be up to 10 to the power 4, and each of the element will be from 10 to the 0 to 10 to the power 6, and k could be up to n plus n minus 1 by 2. So let me discuss the algorithm we do. So if you think like in brute force, we can find all the possible absolute difference that could possible using all the elements present in nums, and then we can sort them out, and after sorting we can find the kth smallest element, okay, in that distance. But that won't be the solution of for this question, because the time complexity will be big of n square in that case. So it will not be accepted for this question. So we will use binary search and find like for binary search, if you think like that, like how many possible sums, like absolute difference could be there from 0 to up to, like from the maximum different absolute difference will be the maximum element present in nums minus the minimum element present in nums. That will be the maximum difference, and the minimum difference will be 0, because if there are two elements present, so the absolute difference between those will be 0. So the kth smallest distance will be between 0 and the maximum possible sum that could possible by using the elements of nums. So we will find, like we will use binary search between these two ranges, and we will find for each of the, like first we will find like the mid position, and we will find how many pairs are there in the range from left to that mid position. Okay, and we will check if the count of number of pairs are less equal to k or not. If this is less equal to k, that means we have already like founded more than k element, like more than k pairs, which have the like sum minimum, which have the minimum sum. So we need to bring the right side pointer to the mid position, and if we do not find at least k elements or at least k pairs, then we need to bring the left pointer to the mid plus 1 position. That will be the binary search. And how we will count the number of pairs which have the like sum, absolute sum, like absolute difference less than or equal to k. So to find that, first we have to sort the list or sort the given array. And then if we sort the array, then you can understand, if we use sliding window algorithm, then we can easily find the count of pairs which have the sum less than or equal to k. So we will use a pointer, left pointer and right pointer. We will check each of the, for each of the window. We will first count the right minus left value, and we will check that if the value is less equal to k or not. If the value is less equal to k, that means all the pairs that could be possible in that current window will be the added in the count. Okay, you will see how the code will work. So first we need to sort the given array. So nums dot begin and nums dot end. Next, we need the two pointer. For binary search, we need two pointer. The left pointer will be mn, like minimum absolute difference will be 0, and let's say mx will be the maximum, which will be nums of nums dot size minus 1, the last element, minus the first element, which is nums of 0. This will be the maximum difference that could possible. So we will use binary search while mn is less than mx. First we need to find the mid which will be mn plus mx minus mn by 2. This will be the mid position, and we will check how many count of pairs are there. So to find that, if find count of, let's say, nums, and the sum will be, let's say, mid. Okay, we will find how many count of pairs are there which have the absolute difference less than or equal to mid, and we will check if it is less equal, sorry, greater equal to k or not. Because if it is greater equal to k, that means we need to bring the right pointer to the mid position. So right pointer is mx equal to mid position. Otherwise, else we need to bring the left pointer to the mid plus 1. So left pointer is mn equal to mid plus 1. Okay, that's it. And after that, when the mx and mn are same, then we just return the mn. Now we need to find the count. The return type will be int, and this is the code. First is nums, second is the mid, or you can say the sum. Okay, we need to find which have the sum absolute difference less than or equal to the sum, or you can say, let's say, mid. Okay, first the count is initially 0, and we also use two pointer approach. So we need to left, let's say, l equal to 0, and also r equal to 0 for sliding rule. And while r is less than the nums dot size, we will continue. So first we need to, like, bring the left side up to until, like, we have the right side minus left side is less equal to mid. So first we will check if nums, like, while nums of r minus nums of l, the difference is greater than k. We will do that until the right minus left, the absolute difference becomes less equal to k. Then we can count the number of pairs. Okay, so we'll bring the left pointer one step forward, and then we will count cnt plus equal to, the count will be all the possible pairs, which is either the, like, window size minus 1, or you can just write right minus l. It will be the equal to the window size minus 1. Okay, and next we need to in the art class plus also, and then we need to return the count. That's it. Let's see will it work or not. Okay, it is not k, it is mid. My bad, it is the mid. Let's see, it is accepted. Let's submit it. So it will be accepted. Let me discuss the time and space complexity of this. So for to sort the all the algorithm, it will take big of n log n time, and this whole code it will take for, because we are performing binary search. So binary search it will take log n, but here log n is the, like, not the length of the nums. Here n is the, like, 0, the left pointer is starting 0 and right pointer is the maximum sum. So the overall n will be the log n, the n will be the maximum sum. Okay, and to find the count of pairs, it will take n times big of n times, where n is the length of nums. So you can say for this while loop, it will take big O of in log D or in log in, where you can say in log D, where in is the length of nums and D is the maximum sum that could possible by using all the elements present in nums. Okay. So the overall time complexity will be big O of in log D plus in log n. And for space complexity, it will be big O of constant because we are not using any array or list which is depending on the length of the nums. So we can say the space complexity is big O of constant or big O of 1. Thanks for watching. If you want to check out the code, you will find it in the description box below. That's it for today. See you in the next video.